Okay, is this working? Can you hear me? Yeah? Okay, so this is Test Without Boilerplate. I'm going to be demonstrating some software, and if you want to run it yourself with your laptop, or if the talk's really boring and you want to do something else, then you can just download it as ALib. And the idea is to write tests without boilerplate. So let's go back to the keynote from Rachel this morning, get the API right, and the rest will follow. So what's a test? A test is a statement about your software, or about the system you're dealing with. And you're making an assertion. You want the statement to be true. So a test is a statement that you hope is true. So the simplest test is 2 + 2 = 4. Or 11 times 11 is whatever it is. Or this humongous number is this prime number times this prime number. All these things are tests. So let's see. Sorry, sorry. I need a. What is it? Come on. I want to tab. Okay. Okay. So. Here are some tests. Let's try and make them bigger. Yeah, can you see those? 2 + 2 = 4. 2 times 3 = 6. 1 + 2 + 3 + 4 is 10. All those are true statements. So let's check that. Oh, sorry. You're going to have to forgive me. So that file was called simple.py, and we'll run the tests. They all passed. Yeah, that's the attitude. Of course, you don't believe me. You think all I've done is counted the lines and told you how many lines there were. So how do you know that your testing software works when it fails? So let's try putting 7 times 8 equals. Anybody know what 7 times 8 isn't?
26.
Oh, come on, it's not 54. So if we can save that and.
Sorry to interrupt you. Does anybody else have a mapped PGA data?
Yes.
Thank you.
Do you mean in display?
No,
it's for Tom. Tom should be speaking at this very moment on tests. You chose the right room. So let's see what happens. Oh, excellent. Well, that's promising, isn't it? It tells us that an equality test failed. On the left-hand side we got 56, and on the right-hand side we got 54. I'll pay you later. Sorry, I've borrowed this machine because my machine has got a problem with. Okay, so what we've done here with admittedly very simple things is written tests without boilerplate. That's the point. There's nothing here that doesn't have to be here. Is that okay?
How does it work?
How does it work? Well, I'll come to that later. What else do we want to do with it? Should we do exceptions?
Yes.
Yeah, we'll do exceptions. So let's add one, and if I can find the thing, where is the quote mark? 2 equals 3. And we'll save that. And we'll go back to bash. And we'll get the old failure and we'll get another one. Okay, it tells us that an exception happened. So the left-hand side raised the type error, and the right-hand side was expecting 3. So that's the error. So let's get rid of that failure. What did the software just do? It raised an exception, didn't it? It was a type error, wasn't it? So this is a bit of a cheat, but we somehow want to say that we're going to get a type error, and star star means raised to a power. Yeah, oops, sorry, there's a typo there. Type error. Control X save. Sorry.
Who knows the keyboard shortcut for switching between tabs and bash?
Okay.
Command Shift right back.
Oh, sorry. Command Shift. That's what I was told earlier. What we've got here, sorry, is that we have to put some parentheses in because it's Python syntax. So this expression, oh God. So what was it? Control Shift. Command Shift. That's it. Yay! Okay. So, come on, I'm going to learn this. I've learned something. Okay, so we've got some examples of what can be done. And all this is without boilerplate. We haven't done anything, we haven't imported anything or anything. And all the magic has been confined to the command line, which is the alib. So the alib test library is running that Python for you. And here we've got some tests completely without boilerplates, I think. Okay, so let's go back to the slides, because I know you want to see those. So what's the next question? Okay, so here's something we can do, which is we can write simple examples of how Python works for teaching, for training purposes. Let me show you an example of this. If I can, yes, Control X file. It might be, yeah, alib, sorry, sorry about this, I can't find what I'm looking for. Should be a docs folder there. Okay, let's put that to one side. I'm sorry, I've lost this file for the moment. Let's move on to how it works. Sorry, I'm going to move on to how it works. So if you write an expression in your Python file, such as 3 equals 5, just as a statement, not in an if 3 equals 5, nothing happens. But if you write a statement 3 equals 5 in your Python file, generally speaking, that's redundant. It doesn't do anything. You're calculating a Boolean and throwing it away. So what we do is we take all those statements and replace them by their associated test. So we take that statement and say, oh, that's actually a test. So we'll replace it by the test before we run the Python file. And if you're an expert, we're manipulating the abstract syntax tree to do that. So that's how it's all working, and I'll give you another example of how it works.
What about that star?
Well, that's again manipulating the abstract syntax tree. I'm recognizing that you're computing a power. Now, why would you compute a power and not store the value somewhere? Why would you write 2 to the 5? So it recognizes that in the abstract syntax tree and manipulates it, so it says we're expecting an exception to be raised, exactly this exception.
There's never going to be a syntax error because you're...
Sorry?
There's never going to be a syntax error?
No, because it's not a syntax error. It's something to the something. No, it's all syntactic Python. So if we can, let's see what we want. We want Emacs, Control X file. Sorry. Here we go. Okay, so here's something to think about. What's happening? It'll take you a little while to get your head around it, but I've told you the rules. So this is Python. It executes exactly as Python. So what does it mean? We've got these 4 triples, and for each we calculate A plus B equals C. But that last statement, A times B equals C, is an expression that doesn't do anything. And the system takes it and turns it into a test. So, should get around to applause for that. So let's run the loop, and we're getting 121, 122. I don't suppose you noticed the deliberate error. Yeah, I put a deliberate error in there so that you saw that there was actually a failure, so that you know that the test system was working.
How do we know when it fails? Without looking at our code,
how do you know where it fails? Yes. Okay, at the moment all you know is, well, let's look at what I've reported. Sorry.
We know the output, but we don't know the input.
Okay. You've got a line number, although that only tells you the loop in which it failed. The answer is I haven't dealt with that question. How would you like it to tell you? Would you like the test to have a number? Would you like to know it was the third item in the loop?
I don't know. I wouldn't write a loop.
You wouldn't write a loop in a test? Do you have to test a whole series of values?
Yes.
How would you do that?
Manually.
Manually? You mean you write one test for each?
Yes. You want to use parameterized fixtures with Python. It's an option to get some sort of the actual textual parameters you test, so you can say like doing X and doing Y.
Okay. At the moment, this is version 0.01. I'm putting my faith in something I learned about this morning. Get the API right, and the rest will follow. And it also taught me that sometimes you shouldn't write your slides ahead of time. So that's roughly how it works. So we're saying we have an ordinary file with a special semantics for these expressions. They're actually tests. That's all you do. I'm going to go back to the presentation because there's a few other things I want to do. Oh yeah, what next? Well, I want to have users. I've started using it. And I've learned a lot from that. I've learned that some of the clever ideas I had I don't use. And then a learning materials library. I'll talk about that more a bit in a moment. I'd like to get on to further versions and get to stability. But then there's something really nice happening at the end, which is the tests themselves don't really have anything to do with any language. So you could use Python to write JavaScript tests. Now, why would you want to do that? Because you've got something that runs on the server that you also want to run in the browser. So you want the same tests. Or because you're writing JavaScript, but you're used to using Python. So why don't we write the tests in Python? Because we're used to Python. Or simply because we're doing test-first programming and we don't even know what language we're going to write everything in. So let's just write the tests in whichever language we need. We'll use Python, move over to something else if we need to. Why do we have to specify? If you think about the customer's point of view, the customer generally doesn't care what it's written in. Can't we capture the functionality that doesn't depend on the language without the language? So I'm going to go on to the Learning Materials Library now, if I can. And that's a question of finding a file that is hidden around somewhere. LS. Okay, we'll do it a different way. Sorry, we'll go to... Sorry about this, I'm going to find it on GitHub and then I'll show you the file I'm talking about. So... I'm sorry about the disorganisation of this conference. There we go. Oh no. Why is it not? Why is Google failing me? Here we go. So we can go to Docs. Okay, we're trying. Microphone. Pretend we're trying to teach people how to use dictionaries. So we say the first. Can we make this bigger? Let's make this bigger again. That's big enough. So there's a dictionary, its length is 0. We try and extract something and it's not there, we get a key error. Do you see? If you're a newbie, this is important stuff. If we store something in the dictionary, we can get it out again. All these things are things that you need to know about dictionaries. Here you can delete values. You can say key in dictionary and you'll get true if it's in there, etc. And here's get. People who use dictionaries need to know get. So what I'm thinking of is that this is a really convenient way to communicate to somebody the behaviour of a dictionary. So I've got 10 minutes left and I want to give time for questions and discussion and everything else. So I'm going to stop now and we'll have a bunch of questions. No. Yes. Do we do microphones with questions?
Or I can shout.
Cheers. So you've shown us some tests where you have maths, for example, which is all internal to Python in effect. What about if I want to use this mechanism to test my own code in my own module? Can I do that?
Yes. Sorry. I don't know if I've got it here. Oh God. How about that? So there's an add function and we're testing it.
Can I import my own module though?
Yes. All this is standard Python, except that whenever I see a bare expression like that, I replace it by a test.
Okay.
For bonus points, you could probably template your actual code with tests, like putting asserts in there.
Yeah, asserts would still work, yeah. But all that's happening is I'm replacing that by the test it stands for. You just read it differently and say 2 + 2 = 4 is not a Boolean that I discard, it's a test. Yes.
If I pulled in my own module if I pulled in my own module, would your AST rewrite affect my module? So if I had a sort of a side effecting method that didn't assign, would I get my stuff rewritten?
No.
Okay.
It wouldn't affect anything that's imported. Yes.
Jonathan, this is amazing. So have you looked at py.test?
Yes.
So py.test is almost like this, except that they've got the assert keyword, right? So
and they've got the def, and every test has to have a function name.
Right, exactly. So why? I think you could fork py.test maybe and just remove the assert keyword and like slowly try and transform that project into your thing. That would be great, wouldn't it?
One of the things I admire about py.test is its test runner.
Yeah.
And I would like it to be able to run tests of this nature as well. I'm not sure what I've got here is about 200, 300, 500 lines of code.
Exactly, so it shouldn't be that hard to add that to py.test, which is a huge, massive thing, and then you just improve it by 200 lines of code. Win for everyone.
Are you a py.test user?
Only casually.
Only casually. Can I have another question?
So function calls are the result is often discarded if the intent is the side effect. Are they treated as assertions?
I'm not. I won't touch function calls because a bare function call I'm not going to touch. They will go straight through.
Okay, but if you make an assertion, if you write a.foo equals some value, then you've got an expression.
That's right.
So, okay.
Yeah, two together. To continue answering your question, we're at version 0.0 or 0.1, 0.01, and that means that the answer is whatever you want it to be, as long as you're a developer.
Can you isolate your tests?
Yes. There's something that I've played around with but isn't implemented, which is that this code here is being run in a dictionary. And you can control that dictionary. So in that dictionary you can set a context and you can say slow tests false. And then in your test you can say if slow test... I'm sorry, I'm not... You can, that's the polite word, you can inject stuff into the context. So you can put into this context your test running variables, your test running context, and when you run the test you can inject that stuff in. So you might have a pi2 and a pi3, for example. You want to document the difference between pi2 and pi3, so you say if pi1 do this, if pi2 do this, if pi3 does this, and in your command line runner, well in this case you'll be using the right version of Python, so it will automatically interject pi2 and pi3 into you. But if there's other things like platform that you want to inject into the test, you can do it. In version 2.
I wanted to know if each file is one test, or can you have more than one test?
We've got 5 tests in this file.
Yes, but it's 5 tests, but they feed off each other. I mean, if you mutate something inside this add function, the next test will see it.
If I do what? Side effects I haven't thought how to do. I think that's quite an interesting question, how to deal with side effects, how to deal with mutable objects. I wanted to get everything right on the simple case first. There's something else, which is here you've got a function call. I mean, I think the proper thing to do in a function call is you assume that the function you're calling exists and that the things you're going to compute exist. And if they don't exist, if they raise an exception in their creation, then that's a failure of the test to run. And then at this point you record the arguments to the function when you record the answer. But the basic idea is that we can make tests with very little boilerplate, and also in a way that gives the user much more control. And this works well in this range of examples, and that's why I want users, because actual users will have needs and you can meet those needs elegantly. Whereas if you leave it to the programmers like me, they will invent things that they think are cool. So we want users as a constructive force. Another question, or are we out of time? 3 more questions or 3 more minutes? 3 more minutes. At the back.
I'm not sure if you mentioned this, but how does PEP8 deal with this? Some of our CI servers fail builds if code doesn't comply with Flake 8. So
okay, this code is syntactically correct Python, and I rely on that. If there's a syntax error in there, it won't even get anywhere, because I compile it, but I interfere with the compilation after the syntax checking has taken place. So if we put a syntax error in here, I will get an exception that will say that this code is invalid. Do you want to see that happen?
Yeah.
Syntax error. How do you do a syntax error? You simply write an ampersand. That will do. More importantly, how do you run bash? What? Oh, sorry, this is the wrong file. This is the add file that I put the syntax error into. Sorry. I really need an assistant. Yes, I know how to do it. Lou. No, add. Sorry, just a moment. Sorry, there's your syntax error. Yeah, what's it?
I don't think nothing said that.
Can I run what?
It's okay. Your time's up. So, Jonathan Fine, everyone.